Now that we are moving close to the end of the data link layer modeling, we'd look at the problems and then we'll do some simulations. First, in this module, we should explore and recap basically some topics which we consider to be of problem-based in nature. First, we'd look at the channel performance in the presence of bit error rate. We'd look at the redundancy and the overall framing efficiency in Ethernet. And then we'd look at how back-off algorithm works in CSMA-CD. In order to look into some kind of treatment into real-world systems, which of course you are eventually going to simulate, I've taken these problems from Tannenbaum, Computer Networks, 4th edition. However, you can look for other textbooks as well. Let's look at the effect of bit error rate on channel performance. If we look at an 11 megabits per second 802.11b wireless local area network, if it transmits 64 bytes sized frames without any gap, so it means there is no interframe spacing, over a radio channel with bit error rate of 10 to the power minus 7, how many frames per second would be damaged on average? This is going to be simply a mathematical manipulation. Now let's look at what is the efficiency of Ethernet framing. Assume, although it is not a widely adopted assumption, but for the sake of mathematical treatment, let's do it, that we have 1 kilometer long CSMA-CD LAN, because we agreed that using repeaters, CSMA-CD based LANs can go up to a length of 500 meters. And anything beyond that is going to cause problems. But for the sake of simplicity and just assumption, we take 1 kilometer long 10 Mbps CSMA-CD LAN. This is going to have a propagation delay for 200 meters per microsecond. You can determine the speed for yourself. Assuming that repeaters are not involved in the system, because if the repeaters were involved, then the RRR operation also takes some time. If the data frames are 256-bit long with 32 bits of header, checksum and other overhead, if the data is sent like this as 256-bit total length, and as an acknowledgement, the first bit slot after a successful transmission is reserved for the receiver to send an acknowledgement of 32 bits minimum, you are required to give the effective data rate excluding the overhead, assuming that there are no collisions. It means you can consider two computers placed on the farthest ends of a kilometer long LAN. Now we'd look at the performance of binary exponential back-off algorithm. If you assume that there are two computers that are trying to transmit a very large file, if these files from each of these computers consists of multi-frame, and assuming that after each frame is sent, these computers compete for the channel, continuously sensing the channel, using the binary exponential back-off algorithm, do a small mathematical treatment, that is, find the probability that the contention ends on round k, and also determine the average number of rounds per contention period. Please note that the hint is within the name binary back-off algorithm. It means every time there's a collision, the likelihood of taking the silence interval increases.